Okay. Okay, there goes the recording. So yeah, there's been a lot going on. Maybe we can just start out if we want to have Pierre do a quick readout of the various technical things that have been going on over the last 2 weeks since our last formal meeting. I want to put you on the spot.
Sure thing. I guess the biggest one was or do we already spoke about AutoSD at the last meeting? I was away last week, so my timeline is entirely mixed up. Jeffrey, do you remember if we spoke about AutoSD last time?
We did have talk about AutoSD, and I can even bring up the slides if you like.
True.
It
So
wouldn't
yeah, we
hurt
did.
to refresh. There's no harm in.
All
I'll
right.
tell you from personal experience, repeating yourself is sometimes helpful. So,
Are these visible now?
not yet.
Not the slides yet.
Not
Yeah,
there.
they're coming.
Perfect. Yeah.
Okay.
And I've shared on the chat the blog post that we've published on blog.centos.org about AutoSD. And the idea of AutoSD is to have a public development version of the in-vehicle OS that Red Hat is working on, where we can collaborate and have then the Automotive SIG sit on the top of the AutoSD project and expand upon it. So if we want to do new hardware enablement, if we want to do test some features on the kernel, change some things on, I have no idea, systemd, GCC, or whatever, we can do that as part of the SIG without impacting the program, the project, the product that Red Hat that wants to work on. But also that's also a way for the SIG to actually contribute back to the project by demonstrating that, hey, look, we have these patches on the kernel and we have made them and it works, it's stable, we can test them, we can work upon them, and then we can knock on the Red Hat store and say, hey, we can prove to you that it is working. We can tell you that it is desired. So please have a look at it and consider it consider including it into your product. And being as close to the product as possible by sitting just on the top of AutoSD would give us that possibility of showing Red Hat what can be done with it. The idea is that AutoSD would be the equivalent to the in-vehicle OS of what CentOS is to RHEL. So it's very much the public in development version of the product. So everything everything that arrives on AutoSD should be landing in the product down the line. So if you want to see, what the product will look like in 6 months, basically AutoSD is the place to go. And when I'm saying 6 months, don't hold the timeline in there. There is a much clearer timeline between CentOS and RHEL, and I don't know that the timeline has been established yet between AutoSD and the product. So I'm saying 6 months, but that's just an example. I have no idea actually what the turnaround between AutoSD and the product will be. That's about it. We have on those changes that have happened, we have you can actually start browsing it. So if you go to https autosd.sig.centos.org, you can see there is, I like doing that with you. There is a product build. This is going to be renamed because it doesn't mean much. But the product build is basically the current state of the AutoSD project. So it's a YUM repository with a number of RPMs. You have a latest folder with CS9, and then the folder structure is being reorganized because there are things like we pull RPM from different sources, the different channels in RHEL, the different channels, equivalent channels in CentOS, and that information does not bring anything to AutoSD, so it's going to be trimmed down a little bit. We don't need to know, what was coming from upstream code ready builder or base OS. So it will be a little bit simplified. The product build folder is going to be renamed as well because AutoSD is not a product, so that doesn't make sense. But that's the idea. You can see as well at the top that you have a sample image folder. The images, this is also going to be reworked. The images there I don't know they have been worked on by the pipeline that triggers when we have a change done in CentOS Stream, and that updates AutoSD based on the change that are happening in CentOS Stream. But for example, one of the things that is missing here is we don't know how old these images are. We don't know when, what they correspond to. So this is also going to be reworked. It's work in progress. So soon we'll have in place an easy view onto AutoSD, as well as sample images that we'll be able to download and use, which should be a little bit nicer than the Pingu.Fedora people space that we are currently using for hosting pre-built sample images. They are handy, but it's better. On the technical side, Alexander has also just sent an email to the list about some of the work he has been doing around containers, and there is a fun set of containers that interact that talk to each other via some IP, and that you can basically build an image with the container pre-built and systemd starting the container on boot, and have the container talk to each other using some IP as the underlying message bus, I guess. We've edited the documentation quite a bit as well. If you haven't read it, have a look at it. And that's for the most visible part of what we've been doing. We're still working on the CentOS infrastructure side about enabling, a nicer workflow. So we're working the look-aside cache structure, which would allow to develop a more flexible Git structure, because currently when you upload the source to this Git on CentOS side, it incorporates the Git branch name because of the way it's currently linked. It's currently set up, but by moving with GitHub, we can drop the Git branch structure that was currently imposed. But the look-aside cache relies on this structure, so we are working on changing the look-aside cache structure so that we can drop the Git branch requirements on the Git side. So that it should just make our life easier down the line. That's the gist of it. dropping hard-coded structured and decisions for a simpler workflow. I don't know if there are any questions. Yeah, the doc has been updated. We've we start by presenting the different artifacts that the SIG is working on, AutoSD, the Automotive SIG repository, which expand on the AutoSD, and the sample images. And then you have instructions on how to build them and so on. I've been rambling now for 5 minutes or more, so I'll give space for other people to run.
We've been hanging on your every word, to be clear, Pierre. It's not.
I don't believe
stuff.
that, but it's nice. It's nice of you to say. Yeah.
I'd be curious or encourage people. I know most people in Red Hat are probably familiar with this, but if you don't know what Pierre means by it, this has a similar workflow to CentOS Stream, only for the automotive product. To explore CentOS Stream a little bit more, it really is, in my opinion, a great improvement that Red Hat has created, starting with RHEL 9 and CentOS Stream 9, and we're trying to piggyback on top of that. So it really does show the head of development is right out there for everybody to see.
I'm also happy to take any questions. I may have, thrown a number of terminology terms, words that may not be, that you may not be familiar with. I'm happy to explain what the look-aside cache is, what the disk structure is, how one relates to the other. If that's of interest, or if there are questions about that, I'm happy to go more into details on this. And I see that we can. I'm just saying that there is an IP address there, which we can now replace with the domain name autosd.sig.centos.org. I'm going to update the documentation.
I'm updating. So yeah, if anybody has any questions, please feel free. This is an office hours. This is just a place for us to kind of chat informally about what's going on.
Jeffro, last meeting, there was some discussion about target. So we have images for Raspberry Pi and container, and you ask people to give you feedback about other automotive interesting targets. Did you get any?
Well, there's been a number of different things that we've discussed over the last couple of months. I haven't gotten any responses to that query in particular, but things that have come up include things like the NVIDIA Jetson. There's hardware is always of a lively discussion whenever it comes up. So we could certainly talk about some of the hardware options out there. Right now, since this is an open source project, anybody admitting somebody. We welcome any hardware enablement that anybody would like to do.
Yeah, I was just curious if you got any specific response, what people are using for developing.
Nothing discussed already. Nothing that hadn't, nothing new. There's a certain of boards that have repeatedly come up like the Jetson. Just so everybody knows, the initial reason that we chose the Raspberry Pi as the initial target is simply because of its ubiquitous availability. Everybody has access to one, or at least they did before the chip shortage started. So a lot of people end up having a Raspberry Pi on their desk if they want to play with real hardware. Is there a specific board that you were curious about?
No. I was curious if there was any input from the community outside Red Hat.
Yeah. We should start maintaining a list of the boards of interest somewhere, possibly on the wiki. It'd be interesting to not only do the boards of interest, but also some of the specific challenges. Cost and availability are always a challenge, but some of these boards are certain to have other specific challenges that we would need to overcome. The discussion going on the chat about the Raspberry Pi 4. I'm in Canada and I have been unable to get a Raspberry Pi 4 for the last 8 or 10 months that I've been looking.
Yeah, so availability is your mileage may vary.
A relative term
at best.
Our Pi supply went dry after the NVIDIA supply went dry, but now they're both pretty hard to come by is the challenge, as is everything other than Macs, apparently.
Mm-hmm. Yeah, I was looking on my shelf for all of the really ancient hardware. I think I've got an original Beagle board and probably I think a Dragon board, a Qualcomm Dragon board 410C about 8 years ago, or 6 years ago. So we'll just have to start digging things off the shelf and putting them back into production.
Right.
Unfortunately,
hard to find ARM64 from 8 years ago.
Mm-hmm. It's also not quite as performant.
There you go.
You can't have everything. Either you want performance or you want availability, but you have to pick.
So, is anybody doing any works on these images or on within the SIG that they would like that they have challenges with that they'd like to bring up? Got a lot of the maintainers are here on the call, so
I plan to when I get my hardware.
Yeah. Reserve that for the meeting.
So this is Philip talking. You know, at least on our side, we don't have any difficulty with hardware. We have tens of board. Unfortunately, many of them are not board you can buy, which are the real board used in automotive project. I asked Stefan on how we could try to find the closest development board that are used by the industry to provide some kind of good match in between something you can buy and something that is significant with what people are trying to do. One thing is sure is that we still have a very recent project where people are using very low-end hardware. Just to give you an idea, we've been talking with people working on a camera to detect if the driver is really looking the road, and you know, when you are under autopilot. And the goal for the full system is €30, okay, which includes the hardware, the camera, the software, the everything. Okay, so it's not going to have 8 cores. It's not going to have 8 gig of RAM. Okay, it's going to be more something like 1 core with multiple microcontroller, maybe a DSP, FPGA, whatever to do the work. And for those type of board, Linux is still necessary because you need to have some high-hand functionality. You need to talk with the rest of the car with a communication gateway. Typically, you need to have cybersecurity built in. And typically, that what microcontroller cannot do. So they need Linux for that. But fitting Linux in such an architecture is a challenge by itself.
Mm-hmm.
And this is sending me to, so I would say, hopefully, you know, Stefan is not on the call. He was supposed to be, but probably is stuck in something else. Is due to come with some board that we could support and maintain directly at IoT BZH to have an image for those board. I still have an issue, and I'm not sure how we're going to deal with that, which is how we're going to maintain the specific part of a board support package and a generic kernel. Okay, in Yocto, typically we have layers, and so you may have like you know, a standard core for the core functionality of your kernel, and then you have, you know, some external file where you have the specificity of your hardware. We don't have that in current kernel config, where more or less we have one monolithic config that include everything. So one thing we are asking here at IoT BZH is whether we could have something somehow similar, where we could have on one hand a configuration that define the generic kernel, and to have some complements that we built, or we had, or we overload, whatever is the term we want to use, to complement this kernel to have some specific for a given board. Without this mechanism, it's very hard to keep a generic kernel in place, because everyone is willing to shift to a new one. So that's my first concern. The second question I think that this SIG has not answered yet is, what is going to be different in between the Linux shipped by this SIG and a standard Linux shipped by CentOS for a specific board? Okay, if we ignore, you know, the notion of board enablement, what are the specific functionality? And typically in the automotive sector, we are asked for skim down of the kernel, because people want to boot in a few seconds and on a very small hardware. We are asked for built-in security with things like DM Verity, you know, activated, but also read-only file system. We are asked for some crypto file system for all the user data. People want to crypt everything. And that's something that is not that easy to make. Okay, there is a lot of know-how before you arrive to build a system where your root file system is read-only. So this clearly would be a difference with the standard Linux as CentOS can ship it. And the other element that is also we see specific in the automotive sector is all the capability to drive the specific devices, especially the CAN. Okay, we've done a lot of work for automotive grade Linux to implement modularity and some way to access CAN from automotive description of the message. And so my question is, where this group is willing to go? Is it willing to focus on the very low level, providing the kernel and board enablement only, or you also look at providing some higher functionality, either on the security side or on the functional side, like the cans, introspection, some IPC mechanism, whatever we may need to have in automotive sector?
I can try and provide an initial response. I think from the Red Hat perspective, our effort so far has been towards moving to enough standardization of the hardware and enough upstreaming of the enablement that we can continue to have a kernel model similar to what we do with RHEL, where we are able to have a shared kernel and the enablement is done in the upstream. Much of it is modularized. You use the modules that you need. I do think it would be interesting to talk about, are there models short of that? Are there integration paths, like, or sort of interim steps along the way to that, where, for example, you could use the images and some of the output that's coming from this SIG, but then swap in something that looks like a BSP in the way that you can with Yocto? I don't think that's really well fleshed out. I haven't seen it well fleshed out in the RHEL or Fedora or CentOS space. We say, what if I do need to bring in an entirely distinct kernel RPM in order to produce an image that can boot? So I think that could be interesting. And we could maybe I suppose, so that's one potential discussion. Is what would that be useful? And if so, which platform, is there a sort of reference platform that would be a good test case for that, where it's difficult for us to boot it with an upstream kernel, an unmodified upstream kernel, or the downstream CentOS kernel right now, but everything that's necessary to boot it is available out of tree, and we want to sort of adapt the concept of BSP. So I think that would be interesting. I don't know.
Just to give you an example, the
Sure.
last ceiling board we received, I think we have 600 patch on top of the kernel. 600, okay. That's to enable all the devices and fancy things you have on the board. Yeah. So sorry, I interrupted you. Yeah.
No. So how many of those patches are ever going to find their way into upstream Linux?
I would say very, very little. Yeah.
Is it?
Very little, and one of the reasons is because most of the time people are not going to spend the time to push them upstream. Yeah. But I think it's a fair point. We try to convince industries that they're not going to be in a position to maintain one kernel for board for 20 years. Okay, because today that's what they do. They have one project, one board, one specific kernel, and they have to maintain that for 20 years. But the industry is not yet to the point they're ready to accept that they have to shift to a standard kernel, because the cost of moving to that standard kernel is too big, and also the risk is too high. So if we are willing to enable them to move to a standard kernel, we need to find a way to pull them in. And as you said, one intermediary step could be to have some kind of separation in between, you know, what is standard in your kernel and what is specific, which we don't have today.
Yeah, and also, I mean, there's a pretty important delineation between, because there are models for, and I think RPM Fusion has examples of these. There are models for delivering out of tree drivers if they can be delivered as modules in a way that's purely additive. I'm sure you're almost certainly familiar with this, but then I suspect among the 600 patches that you're talking about in this case are things that can't just be built as modules.
Yeah, many patches just hack an existing kernel, or some ugly things. Yeah, it's not only new drivers. Yeah.
Yeah, and honestly, when you look at this, is Stefan talking. I'm sorry, I have the wrong wrong nickname because of my Google account, and I wasn't able to change it. But anyway,
You also
the
look
thing
like
is,
you are constantly raising your hand, like
yeah,
in this, so
exactly.
I was challenged by that.
You know, it's a kind of anonymous account, so my hand is quite anonymous. No, I just wanted to add that, yeah, for example, on top of the Xilinx kernel, you have something like 800 patches, and if you look in those patches, you see that there is a big part which are drivers which didn't enter in the mainline kernel for many reasons. I would say the quality of the code is one reason, and or maybe for proprietary reasons too, because they don't want to upstream some kind of firmware which is distributed to special customers. So there are many reasons. So, but quality is one reason, and you see other patches which are, I would say, acts on top of the kernel that wouldn't be accepted mainline just to make those crappy drivers work. So, so at the end, the biggest part of the patches relate to the drivers somehow, but not on the generic features of the kernel.
Yeah. I mean, also, I know you know this when you're saying this, but you're not making a strong case for making it easier to use these things by calling them crappy hacks.
Yeah, sorry for that.
No, I mean, I think it gets to the heart of it. That I would
No,
not.
that's just real. I mean, if
Yeah,
you look at what happens with, for example, Freescale is a good example. Freescale now NXP. They had hard times in the past to push their patches to the kernel. So at some point when you were building some Yocto stuff with NXP or with Freescale, it was horrible. It was a very old kernel with a lot of patches. And they made, I think that when they were bought by NXP, they made some effort to get a good level of quality in the code, and finally they pushed a lot of drivers in the mainline kernel. So now if we talk about IMX6 or IMX8, we are quite at the same level as Renesas typically, or I wouldn't say Intel. Intel is the best citizen in this area. Because quite everything is upstream. Then Renesas and NXP are also good citizens because they push most of the code. They achieve that challenge. And there are other ones like Xilinx, or specifically for very new platforms. It's very difficult to push the patches. So so the jungle is very very different from the where you look at. Yeah, you have very good platforms and very bad platforms from that point of view.
Yeah, as I say, I think all of us who have sort of landed in this and are seeing it in this level of detail for the first time understand that any new piece of hardware right now that arrives here, if it runs Linux at all, almost certainly has some element of what you've described. And so I think path one for that is BSPs are then generally associated with Yocto. Yocto is built to allow this to happen. Fedora and RHEL and CentOS generally. It's not that they aren't, it's just they don't facilitate it the way that Yocto does. And I feel like Ubuntu has landed somewhere in the middle where they make it easier to generate an alternative kernel to install with things. So, and I don't think there's no reason we couldn't do that. It has been done in the Fedora space repeatedly. It's just people kind of hold their nose when they're doing it. Whereas if we could present it as a step along the way towards upstreaming, for example, that would be better, which is certainly the path that we intend to continue taking on the Red Hat side. It's what we've done with the enterprise product. There's, with the one notable exception of the very famous out-of-tree preempt RT patches, there's nothing that's ever shipped in a RHEL kernel that isn't upstream.
Yeah, and I think that's a point we probably have to find a way on how have a standard kernel model and some capability to do some customization on top of it, because as you say, some component will never enter in the mainline. I just take one example, which is the advanced IP processing driver from Qualcomm. Okay, that is never going to enter in the kernel. That is quite widely used in the automotive industry because people want to have the firewall running in the DSP and not in the kernel. This also allows you to continue having a TCP/IP stack when you stop Linux, okay, which is sometimes very, very useful. But I agree with your point. Nothing prevents us from doing something that could, mitigate both requirement and find an intermediary step before we arrive to more standardized hardware, which is not going to happen in the next 5 years. Okay, it's going to be longer than that. And to be honest, creating a reference for a good kernel configuration is not that easy. As I said before, if you want to have a read-only file system, if you want to have the MBRT embedded in, if you want to have real-time options and so on, there is a lot of work to do that is completely independent of the hardware. And so if we could have some nice model to do that separation, it would be very useful. Yeah. And we don't have to go as far as Yocto, because Yocto is a nightmare. People can change any option at any time, which is make your life impossible. But we need some way to do, a minimum of customization. I think that would be coming back to what could be unique to this automotive CentOS distribution. This could be one of the points. Okay, today there is no Red Hat, CentOS, Fedora distribution where people can tweak the kernel without breaking everything. Okay.
Yeah, sorry. I just wanted to say that nothing prevents the SIG from shipping out of 3 patches in a kernel. It's going to be a different kernel than the one that lands on AutoSD, but we also have RPM repository on that is available to the SIG. So if we as a collective, we want to create a kernel that, Raspberry Pi 6 or some of the changes that Philip, which is probably more pragmatic than the Raspberry Pi 6 that does not exist yet. That's something that we can do. We can totally have a dedicated branch in the sources of the kernel repo where we can, configure the kernel the way we live, we want it, and experiment with that. It's one of the strengths of the SIG is that we can actually experiment with out of 3 patches, out of string patches earlier than OSD made. I have no idea if anything I've said has reached anyone because all the videos are completely frozen on my hand. Okay, thank you.
I can hear you. Yeah. At least at IoT Business, what we do with our customer and our users is we allow them to configure the kernel like they want. Okay, more or less, for us, the kernel is just one specific RPM. What we don't have today, and what we provide to them pre-built is all the binary for the packages, which is already a lot of time that they can save. The difficulty when you do that is to make sure that you test automatically what has been built, because obviously you want to know if it works or not. And the more you build version and flavor of your kernel, the more you have to run test, which means you need to have a lot of hardware and a lot of CPU to do all that work. But we would love to have an intermediary solution with some kind of reference configuration for the kernel and not tell people you can do whatever you want, but you can do modification on something we have tested. I think that would be a big plus because people do a lot of mistake by making their own stuff. And very often they don't need that many modification. Okay, they pretend they need a lot of modifications. They need something that is 100% specific, but it's not true. Most of the time, they could use something that is 90% standard and have only 10% customization. And today we don't have that mechanism. It's either they use the standard kernel we ship, or they use something they build themselves. And we don't have any intermediary. And I'm not aware of any distributions that have this model to have intermediary patches on ongoing kernel outside of, as we said, of the module and building the module out of tree, which is not something that the embedded community is ready to accept yet, even if technically I think it's a good solution. But I'm not going to fight with my customer for them to accept that. Okay, I think they're not to that level yet. They want something static. They want to do static analysis. They want to make sure how much the kernel is using. And we have customers who run their board full time at 90% of CPU usage and 90% of memory usage. So the margin you have is 10% on each side. So they don't want anything dynamic. Whether it's a good or bad idea is another story, but that's the way they do the work today.
Yes, Ian.
The only way, I mean, the way that I'm aware of these modifications being transmitted such that they're useful, I'm not aware of anything other than the Octo model. And the Octo model is not only do you have the patches, but you also bundle them up in a way that is sort of compatible with the packaging system for the distribution you're using. And so I guess I'd first ask that, is that jibe with your experiences? You end up having to, it's not simply that you have a bunch of patches, it's that you have a ready-to-use BSP, but a BSP is really something that applies to a very specific reference operating system.
Yeah, it is true. That's the way it's shipped by Yocto. That's for the good news.
But that's
the bad news is usually it's not working. Okay.
So you have a bunch of patches, and again, you just not selling this very well.
Yeah, it's.
I kid. I'm just trying to think. The analog for us would be to demonstrate a way that you could maintain an alternate kernel package build, and we have ways of doing this. So, like, if you look at, in fact. So what you're talking about is a set of patches that are invasive enough that they need the primary kernel binary is different. It can't be the same monolithic binary. And the analog we have for that in CentOS Stream right now, which is related to RHEL, is what we do with RT. So RT is a patch set that touches core kernel functionality and subsystems. And so we have if you observe how those are managed in CentOS Stream, you'll find that there's a kernel source tree for the mainline kernel, and then there's a derived kernel source tree for RT. And the people who maintain RT constantly rebase against the main one, and then they make sure that the RT patches apply cleanly. And so if I were to think of an initial model for how we would support this, if instead of RT, it is Renesas's reference platform, the starting point would probably be something like that, where you have either the upstream as the thing that you're rebasing against, or the auto SD kernel as something that you're rebasing against. And then you have patches in another tree or fork that you're constantly making sure reapply. And then if you do that, and if that works, then you could probably then mostly copy the RPM spec file that turns that into an RPM that can then be used with the image building tooling and everything else. So I think what you're describing boils down to explain how the concepts of a BSP map from Yocto to AutoSD. And I think that's the rough sketch of how it would work. And I think the way to do it, to flesh it out further, would be to decide on something that we would build this way, find something that has a BSP that is a desirable hardware platform to support, and actually do this. Create the source tree, extract the patches, apply them on top of whatever, and turn them into an alternative kernel that can run the hardware. So we just need to choose a piece of hardware and do it. I can't think of a better way to do it without major surgery that destroys the sort of workflow that we have for this operating system. So I'm kind of fishing for a hardware target. Main problem here is we agreed that even the most widely available hardware isn't actually widely available anymore. We can't buy anything.
But that's not going to last. Okay. It's, in the automotive sector, at least as today, the most widely development board was a Renesas board. Any demo, if you've been to CES or to any exposition, that's what people were using because it was available. Most of the development board, you need to sign an NDA before receiving the board. Okay, so it's not going to fly. But yeah, I agree. Finding what is going to be the good reference board for end of this year and next year. I think NXP could be a good candidate. They're pretty easy to buy.
Yeah, I think this is something we could chew on a little bit. I'm looking at trying to read Francisco's reaction to this and see if there's anyone else from kernel and hardware. But if it's something we can buy without an NDA, that has huge appeal. And you're saying both of these they're not supported fully by upstream. Both platforms would deliver a BSP.
One thing that is typically never supported by upstream is the interaction with the microcontroller you have on the board. Okay, most of the ARM board have a microcontroller, either M5, M4, or R7. Internally here, we run Zephyr on those microcontrollers. Some other people run some other stack. But the interaction with that microcontroller is typically never a part of the standard Linux distribution because it relies on specific hardware mailbox. Internally here, we ported OpenAMP to have a kind of standard API to talk with those microcontroller. But that's an example of what people want to do. They want to leverage all the hardware available on the board. Yeah. We could also take a vision board. There are some development board for vision, especially in the ADAS world, but they might be too expensive. I think we also probably have to limit the cost of the board. I think less than 1,000 euro is probably 1,000 euro is probably a maximum for development board.
Bruce has a wonderful suggestion, which is we should put have a wiki page and just start throwing candidate hardware on there and explicitly tie it to this idea of proofing out some sort of interim BSP-like step for that type of hardware. And maybe you could verify, is the Renesas, first of all, could someone verify how to pronounce the name of that company?
Renesas? I don't know. The Japanese people say Renesas, but
Renesas, yeah. Renesas. There's a link to a reference board that Steven Smoogen put in the chat. Is that a good one? Is that one we could start with? Is that the one you're thinking of?
So Gen 3 and Gen H3 is the one that was very popular until now.
Yeah.
Okay. I brought it up earlier, and it was considered to be too slow of a CPU for some of the work that we were looking at it back then. But as in the Raspberry Pi 4 is much faster type CPU. So that was the...
Yeah, the M3 is an old board. We had it for at least 3 years. They have the H3 and there is the H4 as well coming in.
Okay.
But
yeah, and I think it's the importance of this wouldn't actually be a specific end functionality so much as it is an example of it's a way to proof out the concept.
I think it's also important to prove the concept with board people use in development and demos. Because if we don't take the board people use in demos, I made, one thing I think is very easy to understand is no EOM or vendors is going to do a demo at CES with a Raspberry Pi. Okay. That's not going to happen. Okay. University may do some demo and some tests, but EOM are not going to do that. So they're going to come with some more professional boards, Renesas, NXP, Qualcomm, Xilinx, and so on. They're not going to come with, consumer boards. The other element that I think we should not forget is the industry is running on very cheap board. So most of the problem we have today running Linux is to run Linux with limited CPU, limited RAM, and on very specific devices. Because if we're talking about running on a big screen, okay, then there is no issue. You can run any Linux. You can also run Android, which some people do. So that's not an issue. Okay, the issue is really to run, and the strongest market today for Linux in a car is on the controller gateway, on the on the LiDAR. You say LiDAR, or how do you pronounce that in English? LiDAR. Okay, so LiDAR, typically they have a real-time operating system to detect all the points, but they have a Linux to put some name on the object. Okay, it's a truck, it's a car, and typically this is done by Linux. But they use very, very small chipset to do that. So if we produce a system that is only able to run on big boards, okay, it's not going to be used by the industry. So we also have to prove we can run on cheap and small boards, which is like one core, 500 meg of RAM, and let's say 1 gig of CPU of a clock. Okay. But we're going, if there is a wiki, we're going to do some proposal. Okay, I'm going to ask my guy to come with some proposal. Yeah.
We can push something. I was replying to Stephen. In fact, if you look at the Renesas models, you will see that there are plenty of let's say inheritance in their SOC models, because they have let's say a generic one. M3 was one, H3 is another one, and then they have some kind of specialized chips for different applications in the car. Typically IVI, or IVI will use I would say middle range SoC with graphics and multimedia capabilities. If you look at the instrument cluster, it will be something smaller. You will have less cores, maybe less multimedia capabilities, but still you can have a CAN controller. So you have common IPs in each SoC, and you have specific ones. And the one pointed by Stephen is, for example, for ADAS typically, because they probably added an NPU for analyzing or to make some kind of deep learning about, I don't know, what the cameras will return, or whatever stream they want to analyze. So and Renesas is doing like this because they want to optimize the prices probably, and they pay for external IPs to other companies. And so if you look at NXP and other SOC vendors, you will see quite the same habits in specializing their SoC for specific markets. So it gets also even more difficult to support these in the kernel, because you see that there is a huge range of features to support, and you can use a generic Renesas kernel to say, yeah, I'm able to boot the board, but at some point you will have to do something specific to really use that NPU or that GPU or whatever IP specific you have in the SoC. So that's a challenge for production, but maybe not for this SIG, in fact.
Thank you. That helped me. I had been looking for. I'd seen a couple of demos, and I was trying to find the boards that were being used. But one of the issues was the demos were, of course, pre-COVID, and the boards were now fairly old. And so I'm trying to find what is a equivalent to the H3 system that would be useful towards a demo system.
I don't want to disclose anything, but what I know is that for example, the next generation SoCs at Renesas are out now or this quarter, but the boards, yeah, but the boards are not there yet.
Yeah, I figured that would be the case. That
that's the same for Raspberry Pi, because the SoCs are there, but you know that you are missing some resistor.
We're missing all those other little tiny chips that
exactly
make it work.
Exactly, and maybe copper. I'm not sure.
But to come back to the discussion we had before, if the SIG could help finding a solution on maintaining, customization on a kernel for 20 years, which is a requirement from the industry, it would be a big plus. Okay, I don't have the answer, but clearly that's a big issue. And every people we're talking to, even when we say, we can propose to maintain the kernel for 10 years, they're like, this is not enough. Okay, we want 15 or 20 years. So clearly we have a lack on the technology today, to tell people, we can take your specific part, try to minimize that, to isolate this specific part, and we can glue that to something that is more standard, that has an official maintenance for a long run. And we don't have the right tools today for that. And yeah, this would be clearly something we would love to have. I don't have the magic answer, okay? Let's be clear. I don't have a magic wand, but it's a big issue, yeah.
Look, my question comes down to, I've heard people wanting 20-year support for 20 years now. I've never seen anybody put up the money for 20 years support.
Yeah, but the requirement today, if you look for the new regulation, UN R 155 and 156, they impose to maintain the system for the full life cycle of the device, which includes the car. And the average age to put a car in the trash in Europe is 20 years. That's the reason why they're looking for 20 years. And everyone understands they're not going to do some functional update. We're talking about, important or critical security vulnerabilities they want to fix. But this still means that you should be able to do some modification on existing system for a very long time. And I agree with you, okay, 20 years is probably a dream, but even 10 years is a big issue. And today what they do is they have one specific kernel for every system they ship, which is not going to fly. So that's, in my opinion, that's the first thing to fix, is to make sure that they stop having as many kernel versions they have project. But if we want this to happen, we have to provide them with some tooling.
I wanted to mention is that there are some parallel efforts within the Linux community around this kind of long-term support for 10 to 20. The Civil Infrastructure Project has been working on this for about 10 years.
Yeah, we are part of that project, but honestly, I don't think it's going to fly in the automotive sector. It's, yeah, they made too many assumptions on the hardware, and they're not as much driven by costs than the automotive industry. Yeah, the automotive industry is really mean. If they can save €5 on the hardware, they're going to save €5.
If they're going to what is it, a cent? Is it a cent in euro?
Yeah.
Too, because when I dealt with this back in the 90s, if you could save 4 cents on a chip, you went with that chip on a motherboard. Whether
yeah, it's true. Yeah, it's they can remove a capacitor, because they arrive to the conclusion that the capacitor is not mandatory. So you're right. It's like 5 cents. Yeah. It's
or they are using bad cables typically.
Yeah.
I mean new bad cables.
Hey, aluminum is just as good as copper. Don't believe the press.
Exactly.
And steel is just as good as aluminum.
I want to believe. Okay, well, we're at the top of the hour. Love to, preserve as much of this conversation as possible. I have my own notes that I will keep. And anybody, if you want to, please feel free to add some hardware ideas. I just posted the page. I set up a wiki page for hardware ideas. If it's okay with you folks, with Philip and Stefan, I'd be glad to add the hardware that you mentioned. And just say, this is just as a starting point. These are the kinds of boards that we are looking at, and hopefully people will be able to contribute to that. The CentOS Wiki should be for everybody. Get it.
Where did you post it?
I posted it in chat. I will go ahead and send it out with the meeting.
Is it okay to talk about sloppy work in progress lists of boards there? Does it imply that CentOS supports certain boards, or
I think that we should. It'd be great to mention the things that are going on and to call them out as such. Make sure that the status on that page stays up to date. Otherwise, if he mentions it, something's being worked on, and if that work completes, but the page never updates. So, yeah, I think this is a great place to do that. That's the dream of a wiki. Anyway.
A wiki is where information kills itself.
Like all gardens, they have to be actively maintained.
Yes. Well, it's nice talking to you all.
Great to see everybody.
Okay, bye bye.
And we'll talk to you in a couple weeks.
Thank you, guys. Bye bye.
Thank you.